Variables and loops, evidence discussion. Welcome to this explainer. Today we're diving into exactly how a Python program keeps track of changing information.
So picture this. You're playing your absolute favorite video game, right? You're running around, grabbing items, and your score is just constantly ticking up. Have you ever wondered how the computer actually remembers and updates that score continuously? It's not like it's writing it down in permanent ink on the screen. It really needs a reliable way to hold on to a value and then update it over and over again as the game goes on.
Well, to figure this out, we have to look at our core tool, which is the assignment statement. The official Python documentation tells us that assignment statements are used to bind or rebind names to values. You can kind of think of variables in Python as dynamic scorekeepers. They hold a value, update it, and then communicate that totally new value back to the program on every single loop iteration. And they pull this off through an assignment statement, which basically evaluates an expression and hands the resulting object right over to our variable name.
Section 1. The evidence. Variables inside loops.
All right, let's look at a real example straight from the official Python tutorial. This is a while loop that calculates the famous Fibonacci sequence. Now, notice how it starts with this initial multiple assignment right at the top. The variables a and b simultaneously get the starting values of 0 and 1. Then, we drop into a repeating while loop that just keeps executing as long as a is less than 10. Inside, it prints the current value of a. But then, we hit that absolutely fascinating final line. A, B equals B, A plus B. This right here is exactly where the magic of communication and dynamic updating happens.
Let's actually trace the first three iterations together as our evidence. So, at the start, right before the loop even begins, A is 0 and B is 1. The loop kicks off, prints that 0, and then both of those variables update. In loop 1, A becomes 1 and B also becomes 1. Moving into loop 2, it prints the 1, A stays 1, but B updates to 2. By the time we hit loop 3, it prints 1 again, A updates to 2, and B updates to 3. This brilliantly shows us how A and B hold their values, communicate them directly to the print function, and then update their bindings for the very next round.
Section 2. The reasoning. How updates happen.
So you might be wondering, how exactly does Python pull this off without totally getting its wires crossed? Well, it comes down to a really strict rule in Python's assignment statement semantics. In our multiple assignment step, where we have A, B equals B, A plus B, Python doesn't just scramble all the numbers together simultaneously. Instead, for step 1, it evaluates everything on the right-hand side first. It looks at the current values of B and A plus B and calculates those brand new objects. Literally, only after those new results are fully evaluated does it move on to step 2, which is assigning those new items from left to right to the targets on the left side, A and B. The right side evaluates entirely before the left side updates. This is absolutely crucial because it prevents the variables from accidentally overwriting each other midway through the process.
And you know, this actually brings up a super common misconception. Some folks think variables are like a permanent record book, just keeping a long history of all their past values. But honestly, that's entirely false. An assignment statement simply rebinds the name to a single new value. When A updates from 0 to 1, that 0 is just gone from A's perspective. The variable completely abandons the old value. A standard variable definitely does not remember a history of its past.
And because variables are only holding on to their current bindings, there's a strict boundary rule we really have to respect here. You must define a variable before you try to use it. If you try to ask the interpreter for a variable you haven't actually created yet, like say just typing the letter N out of nowhere, Python is going to stop right there in its tracks. It will raise a name error stating that the name N is not defined. It's kind of like asking a scorekeeper what the score is before the game is even started.
Section 3. Knowledge check. Loop tracing.
Okay, so here is your challenge for today. We have a for statement using the range function. For I in range 5, print I. I want you to trace the variable I as the range function generates an arithmetic sequence. We know it starts at 0. But think about how the variable I is rebound on every single iteration of this loop as it goes up to, but not including, 5. So what is the final number printed to the screen?
If you guessed 4, you hit the nail on the head. The final output is 4. You see, the range 5 function generates the sequence 0, 1, 2, 3, 4. As the Python documentation notes, the given endpoint, which in this case is 5, is never actually part of the generated sequence. Because the variable I updates on each iteration and stops right before the endpoint, the very last time it communicates its value to the print function, it is holding the number 4.
Section 4. Final takeaway. Variables communicate.
So, bringing it all together, we can confidently summarize that variables are dynamic messengers. They aren't just static, empty boxes sitting there. Inside of loops, they dynamically hold a value, update it based on the assignment rules we set, and communicate those latest values back to the program to keep things moving forward. Whether it's printing the next Fibonacci number or stepping through a range sequence, variables do the essential work of carrying the current state from one loop iteration to the next.
But before we go, here's a provocative thought to leave you with. We now know that standard variables rebind to new values and completely abandon their old ones. So, what if you actually did need to remember the history? How would you design a program to keep a record of every single score that happened during a loop, instead of just the newest one? Well, it turns out Python has compound data types, like lists that are specifically used to group together multiple values. Exploring how to use those is a perfect adventure for your next lesson. Thanks for joining me on this explainer, and keep exploring.